Hello Year 10. In this question we're told a father's age is the square of his son's age, which we'll define as x, and we're also told that in 20 years time the father will be 3 times as old as his son. And the question is, what are the ages of the father and son? And I'm reading this to mean what are the ages now. So if the son's age is x right now, what is the value of x? And then naturally x squared for the father. So I think to tackle this question, I might start by drawing up a line to represent time. And let's say the beginning of this timeline, let's just define that as now. And the end of the timeline is in 20 years' time. And let's think about the information that the question tells us. So right now, we're told the son has an age of x, and the father has an age that is the square of the son's age, or in other words, x squared. So that's what we're told about now. In 20 years' time, well, we can know that if the son was initially x years old, then in 20 years' time, he will be x plus 20. And the father, we're told in 20 years' time, is triple the age of the son, or 3 times as old as the son. So if the son is x plus 20, then the father would be 3 times x plus 20. So I'll write that as 3 bracket x plus 20. And I think the key to this question, the way we can set up an equation that we can work with, is to link the 2 different representations of the age of the father. Because to go from x squared to 3 bracket x plus 20, we know that there has been plus 20 years in between those 2 points. So I can link that up by saying, I can say that x squared, whatever that age was, plus 20 years, that will be equal to 3 times the x plus 20. I know those 2 things must be equal. And given that, I can now solve this equation for x and see what I get. And because I have a power of 2 here, I can expect that I may get 2 solutions, and I'll just have to decide, is there a way to pick one of those solutions over the other? So let's go through that process. So we'll have x squared plus 20 is equal to 3x plus 60. I'll bring everything to one side, so I'll subtract 3x from both sides, and I'll subtract 60 from both sides, so I'll have 20 minus 60 is minus 40, and that's all equal to 0. And now I need to solve this quadratic, and basically I have 3 approaches I could use here. I could factorize and then use the null factor law, I could complete the square, or I could use the quadratic formula. Here, I'm just going to factorize. I've got a monic quadratic, and I suspect I'm going to get whole number solutions, given we're dealing with an age. So let's just think of 2 numbers that sum to -3, have a product of -40, and I'll just write f for the 2 factors. What are those 2 numbers? Well, -8 plus 5 does get -3, and -8 times 5 does get -40. So those are my 2 numbers, -8 and +5. So that means I can directly factorize this monic quadratic as x minus 8, x plus 5 equals 0, which means using the null factor law, I can conclude that x could be 8, or x could be -5, but given we're dealing with age, the concept of an age, it doesn't really make sense for the son to be -5 years old, because we don't really have negative ages. So that means the value we're really interested in is this x equals 8. So therefore we can conclude that right now the son is 8, and the father would be 8 squared, which is 64 years old.
Boom!
And I think that's how we tackle that question. So for me, I think the best way to approach these kinds of problem-solving questions is to have some kind of diagram. In this case, I went with the timeline. And I think just thinking carefully about the information given in the question and how that then allows us to create the equation, I think that's really the hard part of this question. Once you've got your equation here, it then just becomes a matter of working through the mechanics of solving a quadratic and then just being really careful to cross out the solution that doesn't make sense in the context of the question. So hopefully you've been able to follow along with that and it all makes sense, and now this is something you feel more confident being able to do yourself if you had to. All right, thanks for watching and tick boom.